Alright, so the point of this video is to spend some time on YC and YCP. Right, these are these, right, so YC in formula is the area of the centroid in the goal of the area, the surface times or YA, alright, and YCP is equal to IXX over YC times A, where IXX equals this integral over a surface times Y squared dA. And all of this is assuming that you are defining your surface based on sort of the basic picture that looks like this, where your origin is this green point here coming down, and this is J. Okay? So let's talk about a little bit how to do this. First of all, let's assume that we're doing a problem where we have a shape, and our shape looks like this. It's a rectangle, all right? And so here, the best thing to do when you have your shape is here's J, and here's I, all right? And so that this thing has dimensions, this let's say is W over 2, and this is W over 2, and this is from 0 and it goes to L, all right? All right. Okay. So first of all, let's talk about how you would do this totally if you were doing it with your integrals by yourself. So let's take this shape over here. I'm just going to redraw it so it's in a frame of reference we're slightly more comfortable with and less upside down, but still the same frame of reference, which is to say that this is J, here's my origin, this is I, all right? So if this is, first of all, let's talk about this, right? What's the area of this shape? Area equals what? All right, it's WL, right? Okay, that's easy enough. So let's talk about the centroid. YC equals 1 over A times the integral over the surface, all right, Y dA. All right, I'm going to move this to make room to do other stuff. And I'm going to erase the area, assuming everyone here will remember what the area is. Okay? Please remember the area. All right. So YC equals 1 over the area, so WL times. And now we had written before the integral of the surface, but now we're going to break it up. Two integrals. Y dy dx. What are our limits in y? 0 to L. And what are our limits in x? Minus w over 2 to w over 2. Okay? So, 1 over WL times. Now, you might remember how we do this, but let's just go through it. The integral minus w over 2 to w over 2. The integral of y is 1/2 y squared, and we're evaluating it from 0 to L dx. So this equals 1 over WL times the integral minus w over 2 to w over 2. All right. You guys got to catch me when I do things wrong. It's 1/2 y squared. All right. Times L squared over 2. All right. So far, so good? So far, so good. dx. Now, the L squared over 2 can come out, and so this now equals L times w over 2, the integral from minus w over 2 to w over 2 to dx. And that just is going to equal w, so this is L over 2. Da, 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 da. Now, hopefully you already knew that. That the centroid of this shape is located at L over 2. Okay? Now, if I wanted to know what the center of pressure was, remember we said that that is IXX. So let's just calculate IXX rather than, and then we can plug everything else in. So IXX equals, remember, the integral over the surface, and again, I'm going to write it, and it's going to be the same limits as our centroid, minus w over 2 to w over 2, the integral from 0 to L, y squared dy dx. Why do I do it this way? It's because I know there's a y, and so I'm going to have to integrate the y, and so this is the way I do it. So this is going to equal my integral minus w over 2 to w over 2. All right, 1/3 y cubed 0 to L dx. This equals L cubed w over 3. Okay? And now I'm going to say, what is YCP? Well, it is IXX, so L cubed w over 3 over YC, L over 2, times the area, L w. All right? Let's do a little bit of math here. What do we get? This equals L cubed w over 3. All right? This, yeah, sorry, let me just do this. Over 3, and then we have 2 up there, and L squared w down here, which means that this equals 2/3 L, which is slightly higher. Now I know you're going to be confused because you said, Dr. Christopher, you said it's always deeper, but remember our frame of reference, L, 2/3 L, 2L over 3. Over here, right, if we flip this back around to our original frame of reference, here's the centroid, right, and here, so here is YC, and here is YCP. All right, that's how you do these integrals. So now, here's the thing. There are other ways to do this integral, and in fact, your book gives you another formula for the center of pressure, and also gives you a formula for the x-centroid, which I won't worry about now. But it also says that you can say that the YCP equals minus, and again, the frame of reference here is weird. It's going to say minus IXX, okay, at your centroid times the sine of theta over your height of your centroid times A. Now, why does it do this? First of all, what's the difference between this integral and the one we just calculated? Here's our shape before. Remember, we had minus w over 2, or w over 2, and w over 2, and we had, now I'm going to write it like this, minus L over 2, L over 2, and what it's doing is it's assuming that instead of using the frame of reference of the original system, you've moved the frame of reference to the centroid, and so now your integral for IXX at the centroid is going to be the integral from minus w over 2 to w over 2, the integral from minus L over 2 to L over 2, y squared dy dx. Okay, so let's do this integral. Equals the integral of minus w over 2 to w over 2, the integral from, and then y squared again, you get 1/3 y cubed minus L over 2 to L over 2 dx. So this equals the integral of minus w over 2 to w over 2, 1/3 times L cubed over 8 plus L cubed over 8, right? Because minus L squared is going to be minus, and I have a minus there, so I get that plus, and 2 times 2 times 2 is 8. All right? dx. So this ends up equaling, so over here, if we simplify this a little bit, we have L over cubed to the 4th, and then L cubed over 12. And so we get L cubed over times W over 12. All right, so that's weird, right? Now let's come back over here. We can rewrite this slightly, minus IXX, comma, centroid. Now what's sine theta over HC? That's just y of the centroid times A, right? You can write it that way if you want. All right, now this means that you get, when I go back to my formula over here, now I have minus L cubed over W over 12. And remember, the centroid is still what? Still L over 2. L over 2 times LW. for the area, so YCP equals this, equals minus L cubed W times 2 over 12 L squared times W. And so this equals L over 6 minus L over 6. And I know what you're saying, but wait, Dr. Christopher, this is so weird because now I don't get what's happening. All right. Why is it minus L over 6? Well, in the book, they're saying, okay, this is L over 2, right? Now we're going to go down more L over 6. So if I take L over 2, and even though it says minus, we're going to add, it's bizarre, add L over 6, what do I get? Well, I have, let's see, I have 3L over 6. This equals plus L over 6 equals 4L over 6 equals 2L over 3, which is the identical distance we got from calculating it from the original origin. All right, so if you use this formula right here, when you calculate your center of pressure, it tells you how much further down from your centroid your center of pressure is going to be. Okay, now, why does the book give you this formula? Why is it adding new frames of reference? Why is this so confusing? All right, the reason is this. In your book, if you have the 8th edition, which I guess is the newest, on page 76, it gives you a bunch of shapes. It says, well, here is a rectangle, and its area equals the base times the length if this is the centroid. All right, so this is minus B over 2, and this is minus L over 2, and this is L over 2. So there is that the area is this. IXX is then B L cubed over 12. We just showed that, and then that means that I can know that, right? And the centroid is at L over 2. We always know that. Right, boom, L over 2. So it gives you this information, right? Yay. All right, and then it says, oh, for a circle, here's a circle. All right. And I could calculate this for a circle. It's harder. All right. But, all right, obviously, here, this is R. And then my area equals pi R squared. All right. My centroid is 0. And that my IXX of the centroid is equal to pi R to the 4th over 4. All right. And then it also does some values for triangles, and it does some values for half circles, right? So it gives you these formulas in the book, which means you can just look up IXX at the centroid. You can use its formula, which is IXX at the centroid over YC times A, and you put that minus, and you say YCP, and all you have to do is remember that this is down, so this minus is telling you what? Down in the version of gravity, down with gravity, all right? If you don't use that version and you just say YCP equals IXX over YCA and you calculate it yourself, then you don't need to do that because your origin was at the top of the surface, right? So I'll draw our little surface again, right? Here was your origin in green, and so the Y you get is just the right distance for your Y center of pressure, the absolute distance from here, okay? So you can calculate this easily for all sorts of shapes. You just have to be able to set up the limits and go through it, and I will show you in class a number of examples that do that. The fun part and the real trick is this, that for most of these surfaces, and for most of these problems, the real fun part is this, that there's another distance and another origin you're going to be concerned about, and we'll talk about that in class.